Hello guys, myself Chintan over here. On behalf of Mahesh Tutorials, I welcome you all to Bano Vaigyanik, a science camp initiated by Mahesh Tutorials. So today in this science camp, we will be studying about chemistry part over here. Okay. So as we all know, science is basically divided into three streams, that is physics, chemistry and biology. Today we will be discussing about chemistry. But chemistry will study in our day-to-day life. So as we all know from long time, that is from when lockdown has started, we are at home only. And now we are bored of it. And we all want to go out somewhere. So let's go out and let's go to a camp. So we are on a campsite. Okay. And here we'll study chemistry. Isn't it interesting? Okay. So basically what we have to do is very first thing, just we have to observe what all things we can see over here on the campsite. So we can see camps, we can see trees, mountains, water, bonfire, rocks, etc., etc., etc. Now, dear kids, in all these things, there are two things common. That is, whatever we can see around us, there is two things common in all these things. And what are those two things? Very first is whatever substance present around us has some mass. Like we can say camp has some mass, rock has some mass, the water which is flowing has some mass, mountains, trees, bonfire, that is woods over there has some mass. Even we ourselves has some mass. So can we say whatever substance present around us has some mass? Yes. And along with that, other thing common is whatever substance we can see around us occupies space as well. Like camp is occupying some space, mountain is occupying some space, water occupies space, trees occupy space, even we occupy some space. So what we can say, everything around us, either they have some mass or they occupy space. Anything that has mass and occupies space, ये साइंटिस्ट को ये टर्म बार बार यूज करने में कंटाल आता था. Everything around us has some mass and occupies space. So they use a shortcut term for that, which is called as matter. What is matter? Anything that has mass and occupies space is called as matter. What is matter? Anything that occupies space and has mass is called as matter. And matter, based on its physical state, it is classified into three types, or we can say three physical states, which we all know. कौन से three physical states होते हैं? Obviously, it is solid state, that we can see mountains, wood, then camp, all these things are in solid state. Then liquid state, that is nothing but water. And third, we have gaseous state, that is smoke coming out of fire, it is in gaseous state, air around us is in gaseous state, etc. So based on its physical property, or we can say according to their physical state, any matter we can classify into solid, liquid and gaseous. But as we are studying chemistry, so we are not interested in physical states. We are interested in chemical properties of matter. So based on its chemical property, matter are classified into elements, compounds, and mixtures. Let us understand over here with the same example of campsite. So now it's early morning, it's looking so beautiful as you all can see over here. Okay. So now we all can see that in between there is burning of coal taking place. So over there coal is present, and coal is made up of which substance? Obviously, it contains carbon. So a small piece of coal contains tiny, tiny, tiny atoms of carbon. So over here, what is carbon? Carbon is nothing but element. And what are elements? The simplest and indivisible form of matter is called as an element. Simplest form. Okay. Ekdam simple, ekdam basic and indivisible. Indivisible means we cannot break it further. As over here we all can see element contains only one type of substance. So we cannot break and we cannot get any new substance over here. Hence carbon is called as an element. Because if we break piece of coal which contains carbon, again we will be getting carbon only. No new substance are formed. So we say it is indivisible. So the simplest and indivisible form of matter is called as an element. Next, now on burning, actually what is happening over there? Burning. So on burning, what will happen that carbon which was present, it combines with oxygen in the air. So earlier, carbon and oxygen, these two are elements. But when burning of carbon takes place, at that time, carbon combines with oxygen in the air to give us carbon dioxide. And what is carbon dioxide? It is nothing but a compound. So let's see the definition of compounds. When two or more elements chemically combine in a fixed proportion to form a compound. Here we can say there are two or more elements. Obviously, as we saw just now, there were two elements, carbon and oxygen. These two elements chemically combine. Chemically combine means in between carbon and oxygen, a chemical bond is formed. So that is called as chemically combined in a fixed proportion. Now the term fixed proportion over here is very important. Okay, for example, to understand this, let us take one example. If we go to America, if we go to Japan, if we go to Europe, anywhere, formula of carbon dioxide will change or it will remain same. Obviously, formula of carbon dioxide remains same, that is CO2. So what we can say in compound, that is carbon dioxide over here, proportion of carbon and oxygen is fixed. That means in carbon dioxide, always there is one atom of carbon and two atom of oxygen combined. The proportion of carbon and oxygen is fixed. That is one carbon and two oxygen chemically combined to form a compound that is carbon dioxide. So similarly, in any compound, always proportion of their respective elements is fixed. So what are compounds? When two or more elements chemically combine in a fixed proportion to form a compound. And carbon dioxide is obviously a gas. तो गैस कहाँ पे रिलीज होता है? Obviously gas is present in the air. But in air only carbon dioxide is present or other gases are also present? Obviously other gases are also present. So which are the other gases? Let us take few examples. That is nitrogen, oxygen, carbon dioxide, water vapor, etc., etc., etc. So we can say air is mixture of all these gases. And यहीं पे हमारा third term आ गया, that is mixture. Third type of matter, that is mixture. What are mixtures? Mixtures are nothing but elements or compounds are mixed together in any proportion is called mixture. Here in mixture there can be elements also, like we can see nitrogen, oxygen. There can be compounds also like carbon dioxide and water vapor. So these elements and compounds, they are mixed together and proportion is not fixed. It can be any proportion. So such mixture, that is for example air, is called as mixture of gases. So here also we can say it is a mixture. But what we have to understand over here. Okay, we got this elements, compounds and mixture. But mixture, as we can see, it is made up of elements and compounds. Okay. Before that, we saw compounds. Compounds are made up of elements. Like as we had seen, elements are indivisible, but we compounds are divisible. We can break compounds. For example, if it is water, we can break water. We can get two different substances, hydrogen and oxygen. But in case of elements, it is not possible. If we break substance, so just size will reduce, but otherwise the substance present over there remains same. Like carbon, if we break a piece of coal, size of coal will reduce, otherwise substance remains same. So that is about elements. So what we were discussing, mixtures are made up of compounds or elements. Then compounds are made up of elements. What about elements? Elements are made up of what? Correct. Elements, as you all are thinking, it is made up of tiny, tiny particles called as atoms. Okay. For example, if there is a gold ring, this gold ring is made up of tiny, tiny, tiny atoms of gold. Similarly, we had seen earlier a piece of coal which contains carbon. So it is made up of tiny, tiny, tiny particles of carbon. Okay. So what we can say, the basic and most fundamental unit of matter is an atom. So atom is very basic but fundamental unit. Fundamental is something which is very simple, very easy, but it has got great importance. So the basic and most fundamental unit of matter is an atom. So if atom is present, then only elements will form. Elements are there, then only they will combine to form compounds. And if compounds are there, then mixture of elements and compounds will give us mixtures. So if atom is present, then and then only all the other form of matter is present. Otherwise, nothing is possible. So that's why it is basic but fundamental unit of matter. Let's proceed. Okay. So as we are discussing about atom, let us get few more details about atoms. The very first is atomic number. What is atomic number? Very simple. It is the total number of electrons in an atom of an element is called its atomic number. As we all know, atom contains three subatomic particles, that is protons, electrons and neutrons. But atomic number is nothing but either number of electrons or protons. In all the atom, always they have same number of electrons and protons. So it can be total number of electrons or total number of protons in an atom of an element called as atomic number. And the symbol of atomic number is denoted, it is nothing but a capital Z. But as we all know, inside atom, are these electrons present together or they are distributed? Obviously, electrons are not present together. They are distributed, and the distribution of electron is nothing but electronic configuration. So what is electronic configuration? Electronic configuration of an element is the distribution of electrons in various orbits around the nucleus of the atom. Okay, so electrons are distributed among the orbits. So they revolve in their respective orbit around the nucleus. So inside the nucleus, protons and neutrons are present, and around the nucleus, electrons revolve in their respective orbit. But how many electrons are present in which orbit? How we will get that information? So for that, we have to use a simple formula which is 2n square. Okay, where n is nothing but number of orbit, or we can say number of shell. For example, here we have a simple table where four columns are there. First column, we have to write name of orbit. Second, n. Third, formula 2n square. So we have to substitute the value of n and get the final answer, that is electron capacity of that particular shell. Let's do it. So for orbit k, that is first shell. The first shell is also called as k shell or k orbit, where n is equals to 1. So if we substitute 1 in the formula 2n square, so it becomes 2 into n के जगह 1 substitute करेंगे तो becomes 1 square. Now let us solve this. So 1 square is 1 and 2 into 1 is 2. So what we can say, capacity of first shell is 2 electrons. Similarly, let's try for the second shell. So second shell or second orbit is L orbit. Its name is L, where n is equals to 2. So now it is 2 into 2 square. 2 square is 4 and 4 twos are 8. So we get capacity of second shell is 8 electrons, or capacity of second orbit is 8 electrons. Similarly, third orbit, whose name is M, n equals to 3. So it is 2 into 3 square. Again, 3 square is 9 and 9 into 2 is 18. The capacity of third shell is 18 electrons. And finally, we can say fourth shell is N shell, where 2n square, the value of n is 4. So 2 into 4 square, 4 square 16, 16 twos are 32. Electron capacity of fourth shell is 32. That means electrons are divided among this orbit. Okay, so capacity of first orbit is 2 electrons, second is 8, third 18, and fourth 32. Let's see how to write electronic configuration. So for that we have an element over here, oxygen, with atomic number 8. Okay, atomic number 8 hai. That means how many electrons it will have? Obviously, atomic number is nothing but number of electrons. So it has 8 electrons. Now these 8 electrons are distributed in different shells. And always we start filling shell with the first shell. Initially, we fill first shell. If first shell gets completed, then we go to second. If second gets completed, then third, and so on. So let's try and get the electronic configuration of oxygen. So oxygen has total 8 electrons. Out of 8 electrons, 2 electrons will go into the first shell, that is K shell. So hence we have written K equals to 2. So 8 out of 8, 2 electrons are in the first shell. We are left with, or we can say oxygen is left with only 6 electrons. So those 6 electrons will go into the second shell. So what is the electronic configuration of oxygen? It is 2 and 6. Similarly, next element is neon. Now atomic number of neon is 10. Again same, atomic number 10, hence it will have 10 electrons. And again, these 10 electrons are distributed among different shells. Similarly, as oxygen also here, initially first shell will get filled. So out of 10 electron, capacity of first shell is 2. So 2 electrons will occupy first shell. 10 minus 2, there are 8 electrons left. These 8 electrons will occupy second shell. So here we can see both the shells are completely filled, that is first shell as well as second shell. So its electronic configuration will be 2, 8. One more example, that is sodium, atomic number 11. Again, similarly, we'll try to fill this also. Capacity, okay, atomic number 11, so it will have 11 electrons. Out of 11, 2 electrons will occupy first shell, so K equals to 2. Then out of 11, 2 electrons occupy first shell, so now there are 9 electrons. Okay, capacity of second shell is 8 electrons. Can there be 9 electrons in the second shell? The answer is no. There can be less than 8 electrons, but not more than 8. Or simply we can say 2, 8, 18, 32, this is nothing but their maximum capacity. So more than this is not possible. If there are less than this electron, possible hai, but more than this, 9. Okay. So in second shell, there cannot be 9 electrons. Maximum there can be only 8 electrons. So in second shell, 8 electrons are occupied. And now for sodium, one more electron is left. So that one electron will go to the third shell. And with this, we get the electronic configuration of sodium also, that is 2, 8, 1. So here we had discussed how to write electronic configuration. For oxygen, it is 2, comma 6. Neon, it is 2, comma 8. And sodium, it is 2, comma 8, comma 1. Now, we can observe in case of neon, both the shells are completely filled. But, but it is same with oxygen or sodium? No. In oxygen and sodium, we can observe that outermost shell is incomplete. Yes, the outermost shell is incomplete. As the outermost shell is incomplete, we can say this particular element, that is sodium and oxygen, are unstable. And to become stable, what they will do is they will form compounds. And to form compound, they will combine with some other element. And the capacity to combine is called its valency. Okay, always elements combine in a fixed proportion or a definite proportion to form compounds. But the capacity to combine or to form compound is called its valency. And each and every element has different valency. Okay, but how to get this valency? So very first thing, to get valency, we have to write electronic configuration. And for that, we should know atomic number. So if we know the atomic number, we can write electronic configuration. From electronic configuration, we can get valence electrons. And what are valence electrons? Valence electrons are the number of electrons in the outermost orbit of an atom of an element. Simply, we can say electrons in the outermost orbit are called as valence electrons. And from this valence electrons, we can get its valency. कैसे पता चलेगा? So if outermost shell is complete, we can say element is stable. But if outermost shell is unfilled, that is, it is incomplete, completely filled nahi hua hai, then in that case we can say element is not stable, it is unstable. And to achieve stability, that particular atom or element has two options. The very first is duplate state. Now, what is duplate state? As its name suggests, duplate. So, with over there, du means two, and duplate means two electrons. And if one atom has only one shell, guys, listen carefully over here. If atom has only one shell, that is first shell. And if that first shell has two electrons, then we can say duplate state of that atom is complete and it becomes stable. Again, duplate means two electrons, and this duplate state is applicable if atom has only one shell. If there are more than one shell, then duplate is not applicable. It is applicable for atom having only one shell. So atom having one shell with two electrons in that shell, so that duplates get completed and it becomes stable. But in case if atom has more than one shell, then what? Then the other possibility, or we can say it is octet state. Duplate state means first shell should have two electrons, and first shell should be the only shell present in that atom. But if atom has more than one shell, or we can say second shell as the outermost shell, third shell as the outermost shell, in that case what? In that case, atom requires 8 electrons in the outermost shell. And if atom contains 8 electrons in the outermost shell, its octet gets completed and it becomes stable. So example of duplate is helium, as you can see on the screen. It has one shell and two electrons. An example of octet is neon and argon. So as we can see in the neon outermost shell, which is second shell, it has 8 electrons. So we can say octet of neon is complete and it is stable. Similarly, argon. Now, in case of argon, third shell is the outermost shell, and we know capacity of third shell is 18. But still, if there are 8 electrons in the outermost shell, that is third shell, its octet states get completed and atom becomes stable. It is not necessary that its shell should get completely filled. Okay, except for shell, if there is any other outermost shell, over there 8 electrons are required to become stable. That is, that element has to achieve octet state. Octet state means 8 electrons in the outermost shell, except for shell. So if any element has completed its duplet or octet, it is stable. But otherwise, if they have incomplete duplet or octet, then they are unstable. And to become stable, they has to combine. And how they combine? Either by giving electrons or by sharing electrons or by taking electrons. That is giving, sharing, taking. A shortcut to remember is GST. मोदी जी वाला जीएसटी नहीं, यहाँ पे केमिस्ट्री वाला जीएसटी है, दैट इज गिविंग, शेयरिंग एंड टेकिंग. So GST means giving, sharing and taking. So by any one method, either by giving or sharing or taking electrons, atoms or elements become stable. And this give share takes place from the outermost shell or outermost orbit only. Okay. And valency is always a whole number. And what is whole number in maths? You might have studied. It starts from 0. So it is 0, 1, 2, 3, 4, and so on. So that is a whole number. And valency is also always a whole number. Why? Because always atom either they give 1, 2, 3 complete electrons, they share 1, 2, 3 complete electrons, or they accept, that is, they take 1, 2, 3 complete electrons. They do not give half electrons or they share half electrons. No, that is not possible. They give complete electrons, share or take complete electrons, full electrons. So either they will give 1 electron, 2 electron, 3 electron, or whatever it is always a whole number. So its valence is also a whole number. So using this, let's try to find out valency of few elements. Okay, so we have a simple table over here. Very first is hydrogen. So element is hydrogen. Its atomic number is 1. Okay, what will be its electronic configuration? As hydrogen has only 1 electron, so its electronic configuration is also 1. That is, first shell will have only 1 electron. That's it. Next, valence electrons. What are valence electrons? Electrons in the outermost shell. Again, in case of hydrogen, as it has only 1 electron, so its valence electron will also be 1. And valency. Now, how to identify their valency? Just now we had studied two states to become stable, either duplet state or octet state. In case of hydrogen, it has only one shell. And to become stable, that first shell should have 2 electrons. That is, its duplet should be completed. And to complete its duplet, hydrogen require one more electron. So we can say its valency is 1. Similarly, let's try for the other elements. Next is helium, atomic number 2, electronic configuration also 2 because 2 electrons in the first shell. Valence electrons. Again, what are valence electrons? Electrons in the outermost shell, so even that is 2. And valency. Now, dear kids, observe carefully over here. Helium has already completed its duplet. So, duplet is complete. So, it is already stable. Already stable hai, hence its valency is 0. It will not take part in chemical reaction or it will not combine. What is valency? Combining capacity of an element. But as helium is stable, it will not combine, so its valency is 0. Next, lithium. Atomic number 3. Electronic configuration 2, 1. Valence electrons. What are valence electrons? Electrons in the outermost shell. So in case of lithium, outermost shell has 1 electron. Now, lithium has two options. Either lithium can gain 7 electrons and complete its octet, because second shell is the outermost shell. So to complete its octet, it should have total 8. Currently, lithium has 1. So to become to total get 8 electrons, it has to accept 7 more. Or the other option which lithium has got is donate this 1 electron. Because when lithium donates this 1 electron, it is left with 2 electrons and 1 shell. 2 electrons, 1 shell, which state? It is duplet state, correct. So over here, duplet state gets completed and lithium becomes stable. So which one is the easier option? Accepting 7 electrons or donating 1 electron? Obviously, 7 electrons accept karna will require more energy rather than donating 1 electron. Here, lithium donates 1 electron, complete its duplet, so valency of lithium is 1. Similarly, beryllium, atomic number 4, electronic configuration 2, 2, valence electrons 2, that is electrons in the outermost shell. Here, again similar like lithium also, beryllium also donates 2 electrons rather than accepting 6 electrons. So by donating 2 electrons, beryllium also becomes stable, hence valency of beryllium is 2. Then boron, atomic number 5, electronic configuration 2, 3, valence electrons 3. Similarly, lithium and beryllium, even boron donates 3 electrons and becomes stable. So valency is 3. Next, carbon, atomic number 6, electronic configuration 2, 4, valence electrons 4. Now, again, carbon has got all the 3 options available. Carbon can donate 4 electrons, share 4 electrons, and accept 4 electrons. But in case of carbon, donating and accepting is not possible. So by default, only one option is left is sharing. So carbon shares 4 electrons and becomes stable, hence valency of carbon is 4. Next, nitrogen, atomic number 7, electronic configuration 2, 5, valence electrons 5. Again, dear kids, same thing will compare. Even nitrogen has got 2 options. Either donate 5 electron or accept 3 electrons. Which one is easier? 5 electrons donate or 3 electrons accept? Obviously, accepting 3 electrons is easier option. So over here, nitrogen will accept 3 electrons, hence its valency is 3. So 5 plus 3 becomes 8, its octet gets completed and nitrogen becomes stable. Similarly, oxygen, atomic number 8, electronic configuration 2, 6, valence electrons 6, correct? So again over here, oxygen will also gain, that is, it will accept 2 electrons, it will take 2 electrons and become stable. So 6 plus 2 becomes 8, hence its valency is 2. Similarly, fluorine, atomic number 9, electronic configuration 2, 7, valence electron 7, and valency 1. Same 7 electrons are there. Even fluorine has got 2 options, either donating 7 electrons or accepting 1 electron. The easier one is accepting 1 electron. So by gaining 1, or we can say accepting 1 electron, fluorine becomes stable. Next, neon, atomic number 10, electronic configuration 2, 8, valence electrons 8, and valency is 0. Why 0? सोचो सोचो. Very simple. Octet already complete है. Octet complete है तो it is stable. Hence it will not combine, so its valency 0. Okay, moving ahead. Next, sodium, atomic number 11, electronic configuration 2, 8, 1, valence electrons. Again, same electrons in the outermost shell. So it is 1, and sodium also. Again, it has 2 options. Either to complete its octet, it can gain 7 electrons, or simply by donating one electron, sodium can become stable. So over here, sodium donates 1 electron and becomes stable, because after donating 1 electron, the electronic configuration will be 2, 8. So outermost shell has completed its octets, and by that method, sodium becomes stable. That is by donating electrons. Similarly, magnesium, atomic number 12, electronic configuration 2, 8, 2, valence electrons 2 and valency 2. Again, same by donating 2 electrons, even magnesium becomes stable. Same is applicable with aluminium and silicon also. So aluminium also donates 3 electrons, which are there in the outermost shell and become stable. And silicon, 4 electrons are there, so even its valency is 4. Okay, so this is how we can find its valency, or we can find valency of different elements. One thing we have to observe over here is maximum valency possible is 4 and minimum valency possible is 0. Less than 0 valency not possible, more than 4 also valency is not possible. So maximum 4, minimum 0. This you have to remember. Okay. So now as we know how to get the valency, how to find valency, let's try and find out how to write the chemical formula of compounds. Because for writing chemical formulas, we will require valency. Okay, let's proceed ahead and see how to write the chemical formulas. So compound formed by ionic bond has two parts. That is cation, which is basic radical, anion, which is acidic radical. How ionic bonds are formed? By give and take of electrons. So the atom which donates electron becomes positive charge ion, that is cation or basic radical, and the atom which accepts electron forms negative charge ion, that is anion, called as acidic radical also. Okay, so this positive and negative charge, that is cation and anion, as they are opposite in charge, they attract each other and form a bond which is called as ionic bond. And the compound formed is ionic compound. So we can say the name of ionic compound has two words, because ionic compound contains two ions, one cation and anion. So its name also will have two words. First word is the name of cation and second word is the name of anion. Very simple. Okay. Let's see how to write the chemical formula. But again, to write chemical formula, there are few steps which we have to follow. So the steps for writing a chemical formula are as follows. The very first step is write the symbols of the radicals. Okay, cation always we have to write on the left side, anions on the right side. For example, sodium symbol Na, sulfate symbol SO4. This is step number 1. Step number 2, below their symbol we have to write their valency. So below their symbol, that is sodium, its valency is 1. So below Na we have to write 1. And below SO4 we have to write its valency, which is 2. That is step 2, to write the valency below the respective radicals. Step 3, cross multiplication. So sodium we have to multiply by 2 and SO4 we have to multiply by 1. So that this third step, and fourth and the final step is write down the formula after multiplication. So Na into 2 becomes Na2 and SO4 into 1. Anything into 1 remains as it is. So it is SO4 only. So the final formula over here is Na2SO4. And the cation over here is Na, that is sodium. Anion over here is SO4, that is sulfate. So its name will be sodium sulfate, as simple as that. Okay, so what we discussed over here, while writing chemical formulas, what we require is symbol of the cations and anions, or we can say symbols of radicals and their valency. Now to get symbol, it is very easy because name will be given to us, and through their name we can get their symbol. But we have to remember their valency. And to remember valency, there are so many radicals. सबका वैलेंसी कैसा याद करने का रे बाबा. So वो सब याद करने के लिए बच्चा लोग, there is one small trick, and that trick is there on the screen. This is valency chart. So basically, you have to remember valency of all these elements present over here. लेकिन अरे बाप रे इतनी सारी वैलेंसी हम याद कैसे करेंगे तो टेंशन नहीं लेने का to remember this there is a song yes we will sing this full chart or we will learn this full chart in the form of a song let's sing the song okay so it's very simple let's start so 1 2 3 start OH hydroxide Cl chloride Br bromide I iodide no 3 nitrate I iodide no 3 nitrate HCO3 bicarbonate solo HCO3 bicarbonate AlO2 aluminate Ag silver Na sodium solo Ag silver Na sodium H हाइड्रोजन के पोटेशियम H हाइड्रोजन के पोटेशियम सबकी वैलेंसी है वन बोलो सबकी वैलेंसी है वन isn't it interesting okay with similar tune we'll try to learn the other thing also let's start so it is Cd cadmium Ca calcium Mg magnesium Solo Mg magnesium, Hg mercury zinc Zn, Hg mercury zinc Zn, Ba है बेरियम, solo Ba है बेरियम, O oxide S sulfide CrO4 chromate, solo CrO4 chromate. CO3 carbonate so4 sulfate CO3 carbonate so4 sulfate ZNO2 zincate इन सब की वैलेंसी है 2 then the two lines which are there at the bottom copper Cu iron Fe both of them have variable valency both of them have variable valency Copper 1, 2, iron 2, 3. Copper 1, 2, iron 2, 3. But aluminium Al की valency है fixed 3. So by using this tune, we can learn this valency chart very easily. And once you know the valencies of different compounds, sorry, valencies of different radicals, you can easily form the compounds and get the formula of compounds. So by this trick, you can remember valency very easily. So using this, let's try to find out chemical formulas of different compounds. So the very first question is potassium hydroxide. So potassium symbol K, hydroxide symbol OH. Then valency. So try to get the valency using valency chart. So it's valency of potassium and hydroxide is 1 1 each. Step 2, then step 3 cross multiplication. So it is K1 into OH1. But generally what we do is anything multiplied by 1 remains as it is. So we don't use 1 or we don't write 1. So it is KOH. Similarly, second, magnesium chloride. Again, first we'll write the symbol. So magnesium Mg, chloride Cl. Step 2, their valency symbol of magnesium, sorry, valency of magnesium is 2, chlorine is 1. Cross multiplication Mg1, Cl2. But as usual, we don't write 1, so it is only MgCl2. Similarly, silver nitrate. Again, silver symbol Ag, nitrate symbol NO3. Valency of silver and nitrate is 1 1 each. Cross multiplication Ag1 NO3 1. But again, as we don't write 1, so it is only AgNO3. Another example, aluminium oxide. So aluminium symbol Al, oxide symbol O. Then their valency is 3 and 2. Cross multiplication, we get Al2O3. So the formula is also Al2O3. So this is how you can write the chemical formulas. And once we know how to write the chemical formulas, now we can perform chemical reactions because we have developed a base, a strong base. We know what are elements, compounds, mixtures. We know what is atomic number, how to get valency by writing electronic configuration. Okay, if we know valency, we can write down the formulas of compounds, and now we'll perform two different chemical reaction over here. So let's see types of chemical reaction. The very first is combination reaction. Now, what is combination? Okay, so as we know, combination is nothing but combining. So when two or more substances combine, it is called as combination reaction. That means when two or more reactants combine in a reaction to form a single product, it is called as combination reaction. Matlab, for example, here we have two reactants A and B. When these two reactants combine to give us only single product which is AB, such reactions are called as combination reaction. In short, what you have to remember is two reactants or it can be two or more reactants combined to give us a single product, that is combination. Let's see one example over here. So over here, burning of magnesium ribbon. So we have to hold the magnesium ribbon with the help of pair of tongs and burn it with the help of burner. On burning, as you can see on the screen, we get a very dense white flame, and this magnesium over here, it combines with oxygen to give us magnesium oxide. So we get white color powder of magnesium oxide, and the reaction is this. Magnesium Mg plus oxygen O2, two different reactants. They combine to give us a single product, that is MgO, magnesium oxide. So what we can say over here, two reactants combine to give a single product, hence it is called as a combination reaction. So this is the very first type of reaction, that is combination, that is combining. Second type of reaction is decomposition reaction. What is decomposition? Decompose means we can say something which is breakdown. Okay. So over here in decomposition reaction, the chemical reaction in which two or more products are formed from a single reactant is called as decomposition reaction. It is complete opposite of combination. In combination, we have two or more reactants and single product. Here it is opposite. Here we have single reactant which breaks down, or we can say it decomposes to give us two or more products. Such reactions are decomposition reaction. For example, AB, single reactant, it decomposes to give us A and B, two different products, hence it is a decomposition reaction. Let's see its example. So your example is very simple, burning of sugar crystals. We all know sugar is white in color. We have to strongly heat sugar, okay? Strongly heat sugar, and there you can observe after some time we get reddish black colored substance, or we can say black colored substance at the end, which is nothing but carbon. And along with that, some bubbles are formed. Water like bubble, it is nothing but water only. And the reaction is this: sugar, which is C12H22O11, due to heat energy, at the end it is we are left with only carbon and water vapor is released. What we can say over here, single reactant, that is sugar, it breaks down to give us two different products, that is carbon and water vapor. So this reaction is called as decomposition reaction. But over here, decomposition takes place because of heat energy, hence it is called as thermal decomposition reaction. So that's it, guys. For now, today we have discussed few basic concepts of chemistry. That is, what is matter, different types of matter, that is, element, compounds, and mixtures. But all this substance, basically, they are made up of atoms. So we studied about atoms, that is, atomic number, its electronic configuration. We learned how to find out their valency. Okay, that is, their duplet or octet should get completed. After valency, we saw how to write chemical formulas, that is using cross multiplication method, and we learned valency chart, that song over there. And once we know how to write chemical formulas, then we saw two different type of reactions over here, that is combination reaction and decomposition reaction. So thank you so much, guys. Hope you all have enjoyed my lecture. See you all again soon with the other lecture. Okay. If you like the lecture, please register for Science Camp. Two more subject lectures are still left, that is physics and biology, which you can understand in the similar manner, that is funny way, or interestingly you can understand. So please join the lecture again. Register for further part. Bye bye. Take care. See you all again soon. Thank you very much.